All right, welcome back. In part 1, we explored why mutation testing is such a powerful tool for exposing weaknesses in our test suites. Now, in part 2, we're getting our hands dirty. So, let's set the scene. Imagine this. Your dashboard is glowing, showing off 90% code coverage. Your CI/CD pipeline is all green, and you feel pretty much invincible. And then, a bug hits production. Why? How did that happen? It's because high coverage is often a lie. It tells you which lines were executed, not which lines were actually verified. And that's exactly what we're tackling today. We're going straight into the engine room to configure PyTest in our Spring Boot project. Our mission? To turn that test suite of yours into a genuine bug-hunting machine. Okay, before any surgical strike, we need to do a thorough gear check and take a look at the blueprint. Preparation is everything. So here's the essential equipment for this mission. I really recommend using IntelliJ just because its Gradle support is fantastic. You're going to need JDK 11 and, of course, a good grasp of the basics in Spring Boot, Java, and Gradle. We're building on that foundation today. Now, I need you to listen very closely. This is a critical warning. This specific configuration we're doing today works beautifully with JDK 11. It is absolutely not compatible with JDK 17. If you miss this detail, the whole thing will fail. So please make sure your environment is correct before you go any further. And here is our mission map. This is a pretty standard Spring Boot project structure, which gives us context for where everything lives. For today's operation, our primary target is right there in the service package. That's where we'll focus our efforts. All right, gear check is done. It's time to activate the orchestrator, our little bug hunting agent, and we do that by adding the ptest Gradle plugin to our build file. So let's open up build.gradle and find the plugins block. This is where we declare our active agent, the thing that's going to go in and attack our code to find all its hidden weaknesses. And here are the specifics. You need the plugin ID, info.solidsoft.pitest, and pay close attention to the version, 1.15.0. This particular version is key to making sure everything plays nicely with our JDK 11 setup. Okay, our agent is in place. Now we head to the control room. This is the PyTest configuration block inside build.gradle, and it's where we're going to fine-tune all the parameters for our mission. First up is JUnit 5 plugin version. You can think of this as the bridge or the translator. It's what connects PyTest to our JUnit 5 tests, making sure they can communicate properly. We're setting this to 1.0.0. Next, we've got reportdir. This is basically the evidence folder. After PyTest has done its thing, this is where it's going to drop all the mission results, a full report on every mutant it created. And now we get to the most important part of this entire configuration, surgical performance. Look, in a real-world pipeline, you just can't afford to run this on your entire project. It would take forever. So we don't test everything. We test with precision. And this slide really shows you why. If you try to target everything, you get a painfully slow feedback loop and a huge resource cost. It's just not practical. But with surgical targeting, you get a fast, tight feedback loop. It costs almost nothing, and you're focusing only on the critical code that you actually care about. This is how the pros do it. So how do we get that precision? With these two properties, targetClasses and target tests. Think of these as our coordinates. We're telling PyTest exactly which class to mutate and which test to run against it, ignoring everything else. And that brings us right back to our blueprint. The targetClasses configuration we just wrote points ptest's laser right here, at the employee service Java file. That's what precision looks like in action. So, with our configuration now fine-tuned for speed and precision, meet me in part 3. That's where we'll trigger the analysis and learn how to read the PyTest reports to see exactly which mutants survived your defense. For the full code snippets and the complete step-by-step guide, be sure to check the Medium article link in the video description below.